In this video, I explain a problem of hypothesis test for the difference of means. Suppose a study was conducted at a major state university to determine whether the mean number of tests sent per day differed between males and females. Undergraduate students. 35 female students and 50 male students participated in the study. These students were randomly selected and the number of test messages they sent on a particular day was recorded. The students did not know which day was going to be used in the study. The computed statistics are available below. Using an alpha level equal to 0.10, conduct the hypothesis test to determine whether there is a difference in the average number of text messages sent by males and females. And these are the data. So we have that the mean of the messages sent for females are 58.1, males is 38.9 in the sample. The standard deviation of each sample was also computed, and the standard deviation was 13.1 and 12.2 for the males. And finally, we have here the information of what is the size of the samples. The student was 50 male students and 35 female students. So these are the number that we have. And we are going to conduct a hypothesis test of 0.10. But notice that if we're going to check if there is a difference in the average, then what we're going to do is just make an alternative hypothesis like this. It will be a two-tailed test because have a no equal. The average of the first population, all the female students, and the average of this population, the difference when you subtract it is different than 0. That is equivalent to say that the two average are different. Well, we're going to research if there is a difference, but the null hypothesis will be then if mu1 and mu2 are equal. So it means mu1 minus mu2 equals 0. So this is the null hypothesis. Because the alternative hypothesis is no equal, then this is a two-tailed test. No equal actually could be because of the difference, greater than or lower than 0, the difference. Okay, so this is the alternative hypothesis, and the test statistics are going to compute this value. So this area to these two tails will be the p-value. If the test statistic is the value that separates the p-value and the rest of the distribution. So the test statistic will be or this number here or this number here. But it will be a number that separates the p-value from the rest of the distribution. So the p-value is this area. This plus this. Let's compute the test statistics. So let's find this value or this value. Let's see. The test statistic, we have a formula for the test statistic, and the test statistics in this case is this, x1 minus x2, the sample, the difference of the sample, minus the difference in the null hypothesis, and the null hypothesis tell me that mu1 minus mu2 equals 0. So this is 0. These standard deviations are given, the means are given, and n1 plus n2 are given. So we just need to substitute this number and use a calculator or a computer to compute this number. I did it, and the answer was 6.84. 6.84 is the value of t, so 6.84 is positive. So I'm sure that this number here is 6.84. This number will be negative 6.84. So this is 6.84. This number is negative 6.84. Because there is nothing that say that the standard deviation must be equal, so we are considering two different standard deviation. Two different standard deviation mean that we need to compute the degree of freedom, and this degree of freedom will be given by a formula. In this case, the degree of freedom is given by this formula. So if we consider that the two standard deviations are different, this is the formula for computing the degree of freedom. So again, we have all the information that we needed. We need actually just the standard deviations and the size of the sample to compute this degree of freedom. Make a substitution that we have here. We have here the standard deviations and the ends. Make it here and find this number. I already did it, and I found that the number is 69.93. If you are not using Excel, but you are using a table, it will be a good idea to round it down, because this number is not going to be in the table. So for people that are using a table, can you use 69? Because the number must be rounded down. So it will be 69. Because we have Excel, we compute it immediately in Excel. We have the p-value will be equal to the t-distribution to tails. If you don't have two tail, if you are using a software that doesn't have two tail, you can compute right tail of 6.84 and multiply by 2, because these two areas are the same. Or if you have only areas to the left, you can write the t-distribution of minus 6.84, comma, and the degree of freedom. Okay, so and then multiply by 2 when you after you compute the p-value. But in this case, we have Excel, so we use t-distribution to tail, comma, and you can use the number 69.93. Press enter and you can get the answer. So the p-value is 2.59 times 10 to the power negative 9. You can find this in Excel, and that means that it's almost zero. Yeah? So it's almost zero. It's very small. It's obviously smaller than the level of significance we are using, 0.10. Because this is very small, the p-value, there is enough statistical evidence to reject the null hypothesis. So we accept the alternative, and the alternative says that there is a difference between the two average amount of test messages sent by females and males. It will be an interesting or another research just trying to check if the average test messages sent by female students are bigger than male students, because I noticed here in the sample that this number is bigger than the other. But that will be a different problem. It will be a one-tailed test. In this case, was a two-tailed test. So because the p-value is less than alpha, then there is enough statistical evidence to reject the null hypothesis, and we accept that there is a difference between the two averages. And this concludes my explanation of this problem. Thank you.